My name is Rob Cornerans, founder, CEO of Advanced Roofing. Started out roofing when I was in high school in Long Island and through college, and was offered a job to open a branch in Atlanta, Georgia from my employer, which I did in 1979. He moved me down here in 1982. And in 1983, I borrowed $15,000 from my dad and started Advanced Roofing and just grew it by doing what we say we were going to do, good quality work, always in the commercial end of things and mainly in the restoration. We started the HVAC division a few years later, but we're going to learn a lot about that today. As you can see in the bottom picture, that's Kevin in the middle, and then Mike to the right, and me and my grandson. So we got a third generation coming up through the ranks, family-owned business. And one thing that we're proud of is that all our divisions, our air conditioning and solar, we all roll up to one entity. We have 570 employees. And what does that mean? That all our assets are under one corporation. So we're not one of those start a LLC for every little division we have. We're financially stronger than most general contractors, and we are licensed general contractors as well. Here, the division was started in 1994. Scott Milan, he's retired recently, and we do have a Class A license. What's that? That's the biggest and best. I mean, we can do anything from chillers. You see the big unit on the left, down to the smaller replacement units when we're doing the re-roofing, and we have a great proactive maintenance division in the air conditioning division as well. So some of the things that's going on now with the, as Kevin mentioned, the indoor air quality. Next slide, please. Actually, we'll talk about the CARES Act first. That used to have to depreciate air conditioning over 39 years. Now with the CARES Act, you're able to depreciate that in the first year. And if you can look at that chart, if you can't see it, but there's substantial savings, $100,000 on a $500,000 job. So that provided a lot more tax incentives to do air conditioning units. And then the indoor air quality, OSHA is coming up with new regulations on protecting employees, as that's their job. They want to protect the health and safety of all our workforce, as we do. We have our own in-house safety division with 4 gentlemen, and our experience modification is 0.56, which is one of the lowest in construction and the lowest in roofing in the United States. So we're proud about keeping our people safe, and especially in the work environment with this corona and everything I read, it's not going away anytime soon with the different variants. So with that, I'd like to introduce our branch manager, our division manager, Paul Murphy. He's got a lot of experience and a lot of knowledge. I really think you're going to enjoy and learn something. There'll be some good takeaways from today's presentation. So Paul, take it away.
Thank you, Rob. Okay, so I've been involved in HVAC since I was a little kid. My father owned an HVAC company, so I always worked with him right away. Have experience all across the board, from chillers to cooling towers, variable frequency drives. So I pretty much covered all of the gamut as has to do with HVAC. So let's go on to what we're talking today. Basics, we'll go through the basics of an HVAC systems. Then we'll go through the health hazards of our indoor environments, and then some solutions to those hazards. Poll time. Does anyone know what a BTU means? Anybody know what a BTU means? Okay, we should have a poll up there. Go ahead and answer the questions, and then we'll tally it up. Okay. Yep, British thermal units. That is correct. So let's go through some of the different terminology we use in HVAC. So as we just described, BTU, British thermal units, the measurement of cooling or heating output. A ton, so you hear a ton a lot. It's not referring to weight. It's referring to the capacity of the unit. So how much it can cool or how much British thermal units it has, or the capacity of it. So 1 ton is equivalent to 12,000 British thermal units per hour. So BTUH. Then we have EER. This is something you see more in a commercial environment, but it's the energy efficiency ratio. calculated with a constant outside and inside temperatures. And then for your residential units, you usually see a SEER. It's seasonal. So basically they're accounting for a typical year's worth of weather. CFM, you probably hear that a lot. That's cubic feet per minute, a measurement of airflow. RTU, your rooftop units. These are usually a self-contained package unit, but an RTU can pretty much be anything on the roof. It could be a condenser on the roof or an air handler on the roof, because we have those as well. AHU, that's always an air handling unit, device used to regulate, circulate air as part of the heating, ventilating, and air conditioning system. CU, if you ever see that, it's condensing unit. Main function of that is a heat exchanger, condenses refrigerant from a gas to a liquid. Then we have a chiller. Some of you may have chillers. It's usually used in larger buildings to facilitate a heat transfer from refrigerant to water or water to refrigerant. It's a closed loop system. Cooling tower, you will see that from time to time on chillers. Sometimes chillers are air cooled, but sometimes they're water cooled as well. So you'll see a cooling tower doing that. Sometimes you have cooling towers that also feed a bunch of water source heat pumps inside of a building. I think some of you guys pretty much have a mix of that. So what a cooling tower does is it's a specialized heat exchanger, which exchanges the heat between the air and the water, is brought to direct contact with each other, and it basically removes the heat through evaporation. That's the end of that. So let's dive a little bit into the condenser section. So what I like to start with is the heart of the condenser, which is the compressor. It compresses the refrigerant and pumps it to the condenser coil as a high pressure refrigerant gas. It's usually very hot, so don't ever want to touch the outlet of a compressor. We have the condenser fan. It's a vital component that pulls air across the coil to facilitate that heat transfer and required to condense the high pressure refrigerant gas into a liquid. That condenser coil also helps along with the condenser fan to remove the heat. And again, the goal is to take that high pressure refrigerant gas and condense it into a high pressure liquid. So remove that. That moves out of the condenser, flies over to the air handler where it hits the expansion valve. That expansion valve's purpose is to change the state of that liquid refrigerant into a boiling, expanding gas and sends it into the evaporator coil. As it goes through the evaporator coil, that gas is boiling. It's kind of hard to think of, but it's boiling because the boiling point of refrigerant is very low. But as it boils, it passes through the coil, and the air passes through the fins and it absorbs heat from the air. This cooling effect also condenses the water in the air, the humidity, and they form on the coil. They are caught in the drain pan and removed from the system via the drain line. The blower motor and wheel, that's what circulates the air across the coil, facilitates a heat transfer between the evaporating refrigerant gas and the aluminum fins, finally sending it through your ductwork into your building, providing you with nice, cool, dry air. To kind of see it all over, this is kind of from start to beginning. We start with the compressor, and then we move up to the condenser. So starting from the compressor again compresses that gas. It goes through the condenser coil. The condenser coil condenses that gas into a liquid. The liquid flows over to the expansion valve where it expands, and then that expanding gas goes through the evaporator coil, sucking out any humidity or temperature heat from the air, and then it goes back into the compressor. So all we're basically doing is moving heat. So pull time, what does IAQ mean? Does anybody have an idea? I like Islands Adventure. Indoor air quality, yes, that's correct. Okay, so indoor air quality. Before COVID, we spent about 90% of our lives indoors, it may be more now, but which was exposing us to all of our indoor air pollution. But none of that seemed to matter to most of us until now. Today, if someone sniffles 10 feet away from us, we give them dirty looks. The things that are indoor air pollutants, besides SARS-CoV-2 are mold spores, viruses, bacteria, particulate matter, VOCs, carbon monoxide, carbon dioxide, ozone, are just a few. You can kind of move over to the next table, and it'll explain where all these substances come from, these contaminants. So your carbon dioxide, your tobacco smoke, viruses, body odors, dust, fiberglass, asbestos, those are your coming from your building occupants or your materials. Dust mites can often be found in carpets, fabrics, and foam cushions. Gases, vapors, odors, formaldehyde, VOCs are found off from your furniture, your carpets, your paints, your workplace cleaners, solvents, pesticides, disinfectants, and glues. Those are usually what those would come from. Microbial contaminants, fungi, molds, and bacteria. Those are usually growing in damp areas, stagnant water, condenser pans. That's why we want to get those condenser pans cleaned. And then ozone. Ozone is an irritant to your lungs that can be made via photocopiers, electric motors, electrostatic air cleaners, and some air purification devices, actually. So that's why we want to get the fresh air in. So another poll, how many droplets of mucus and fluid can a single sneeze produce? We're gonna roll a video after this that kind of explains it. Okay, we got, yep, correct. Okay, so we're gonna roll this video. It explains how sneezes can travel throughout your office.
Are you sick? Don't you dare sneeze on me. Do you know how far your germs can travel? Normally you hold about half a liter of fluid in your lungs. So when you sneeze, you're able to spray as much as a water bottle's worth of mucus into the air around you. It shoots out of your mouth in the form of moist, germ-infested clouds, traveling up to 35 meters per second. That's fast enough to give you a speeding ticket on the highway. Once that cloud hits the air, it expands, breaking up into snotty strings, then a series of different sized droplets, all trapped in a turbulent gas cloud. One brave group at MIT discovered that the biggest droplets can travel up to 2 meters, about the distance between your desk and 2 desks away. But most other droplets? Those travel much farther, up to 8 meters. That's about 5 desks away. Not only that, the germ-infested gas cloud is less dense than the air around it, so it rises upwards, right to where ventilation systems and other people's unsuspecting noses and mouths await. Even though these are relatively smaller droplets, they're probably still teeming with harmful pathogens like the flu virus. Even worse, depending on the ventilation, they can spread through a room in just a few seconds and remain suspended for up to 10 minutes. Now, if you happen to notice someone around you sneeze or cough, you can hold your breath as you move out of range. But during the flu season, that might not even be enough, because there are danger zones everywhere, especially on surfaces like desks, doorknobs, and steel handrails. It turns out the flu virus has been found to survive for 24 hours on a steel surface. And if you touch that surface and don't wash your hands before eating, you may have just gotten infected. So let's say you go into work sick with the flu one day, and you start to sneeze. Now, according to one study, you'll probably only infect 1 to 2 other people. You're clearly showing symptoms of the flu. However, it's going to take a few days for symptoms to show up in other people you've infected. So those poor souls unknowingly also come into work sick over the next few days. And they will potentially infect 1 to 2 more people. In an office of 100 desks, this could mean 10 or 15 sick people by the end of 2 weeks. That's over 10% of the office. And all of it started with just one sick person, you. All thanks to the germ-laden cloud you so generously shared. So the next time you're not feeling great and you're sneezing up a storm, just think about your poor coworkers and take a sick day for yourself and for them.
So that's a great explanation of how water droplets get into the air, and that's how we spread viruses and bacteria and all sorts of kind of things. So we can go over to the next slide and talk about finding the healthy zone. The healthy zone is the three-headed dragon of the indoor air quality is humidity. Humidity levels that are too high can be unhealthy and create an environment that's prime for health risk. The healthy zone we're looking for, as you can see on the chart to the right, is somewhere between 30 to 60% humidity. Where we usually see and what we want to target is probably 45 to 55 is the range usually we see. We see more 50 to 60 in South Florida because we're so humid here. But high humidity levels can cause respiratory issues. They can encourage dust mite life, allow viruses and bacteria to increase, allows VOCs to become airborne, increase chemical reactions, microbiological growth to take place. Low humidity levels can also cause respiratory issues, irritate mucous membranes, allow viruses and bacteria to increase, and allow for the production of ozone. So kind of just to review, we want temperature to be around 68 to 75 degrees Fahrenheit, humidity between 30 to 35 to 60% relative humidity, a pressure of slightly positive pressure to reduce any outside air infiltration. And we want to maintain ventilation throughout, making sure that we're getting complete air changes in every room. What we know about SARS-CoV-2, okay, so as we just learned, it can be in an aerosol from a sneeze, also flushing the toilet, which I found was odd, but they've actually examined that, and flushing the toilet can spread it through an aerosol. It will last about an hour in the air. On surfaces, on copper surfaces, it'll last up to 4 hours. On cardboard surface, 24 hours. Stainless steel surface up to 48 hours. Plastic, 72 hours. This virus is so small it would pass through your filters unless it's attached to a particle or a large water droplet, large enough for the filter to catch it. So usually your sneeze or your aerosol is large enough for a filter to catch it, so you don't have to worry about that. But the actual virons are about 60 to 140 nanometers. So that's equal to 0.06 or 0.14 microns. Poll time, does anybody know who or what is Merv? What is Merv? Let's see. No, that is incorrect. So let's go ahead and go to the next slide. So MERV is minimum efficiency reporting value. So it's a rating of your filter. The higher your MERV rating, pretty much the more bad stuff will be caught. In the chart below, you can see the different items that are caught based on which MERV you have. And then on MERV 13, you can see all the way at the end, virus carriers. So that's not so much that the virus itself can be caught. It's more like water droplets and stuff that carry viruses can be caught. So pretty much even a MERV 13 can't filter SARS-CoV-2 itself. But what we typically see in a commercial environment is MERV 8. It can catch everything from smoke, smog, cough or sneeze, those water droplets in the air. And we see MERV 11 as well. MERV 13 we don't usually see. It usually requires a larger filter frame. So if you wanted to get MERV 13 filters or something above that, you would most likely have to change the setup that you have for your unit. It's something we can do if you need, so just let us know. They are hard to get right now with everybody wanting a higher capacity filter or a larger, better efficiency filter. So we move to the next slide and kind of go over different items. So kind of product comparison here. We have Hepa filters. Hepa filter is a high efficiency particulate air filter. I know a lot of people have been asking me about getting these, but these are usually utilize a powerful blower. And it's separate to your unit. So We don't see these typically on commercial buildings. We usually see them in clean rooms or hospitals. The pros are that they're very efficient at filtering air. They trap 99.97% of particles that are down to 0.3 microns, which is still not small enough to catch SARS-CoV-2. The cons are they require filter changes, just like any other filter. They're also a breeding ground for mold and fungus. They do not remove any odors, gases, or pesticides. They do reduce the flow due to the tight pores of the system. They're generally not used in central systems. Like I said before, they're sold as standalone units. They are very expensive throwaway because at the end of the day, we throw them away. Carbon media filters, we use a lot on banks lately to reduce smells and odors. The carbon filters consist of a carbon impregnated filter fabric or granulated carbon. These filters usually have a foam or fabric filter media that holds the carbon inside. The carbon has a unique capability of acting as a physical filter, trapping particulate, and on a chemical basis, reacting to some odors and heavy gases. So the pros are absorbs odor, some gases, and filters particulates. Usually you can get these in 2-inch filters. So some of your commercial equipment can get these. So if you're interested, give us a call or give your HVAC contractor a call. He can get these for you. They have been a little low on supply lately, but they're pretty good for eliminating any smells if you have an issue with smell. Yeah.
Hey, guy, question here. Is it better to use 2 HEPA filters at main outside airflow entry?
No, well, so usually you'll see a HEPA filter after everything. So you'll see a HEPA after your air handler. So they don't use them before, they usually use them after. So they want the air to go through everything it has to do to get cool, and then they want to filter it. So they don't want anything adding any biological growth. So if you're going to get a HEPA, it requires a large amount of change for your AC system. It's very expensive. So you have to, we really need to evaluate what is the reason you want a HEPA, and then go from there to see if the application calls for it. Because usually we can solve the issue a lot easier via standard filters. Here are your standard foam fiber filters. They're made out of foam, fiberglass, wire, plastic, cloth. Typically, these filters only stop medium to large particulate, but like I said before, we can get these in higher ratings. We can stop smaller particulate. They're usually low cost, low resistance, and they're installed in your unit. The only con is the air only passes. It only cleans the air that passes through the filter, like any other filter would work. And then particulate would build up on the filter, causing a breeding ground for bacteria if you don't change them. So that's some of the bad things about filters. We always, I would suggest a Merv 8 for your filter. And then if you get something like a bipolar ionizer or a needlepoint ionizer, so we can kind of go into this. Basically,
this to the Merv point, the Merv 8 point. We have another question here. Do higher Merv values cause blower motors to labor?
Yes. So you want to check. So this is the thing with Merv ratings. You can get Merv 13 filters or Merv 11 filters in 1 inch. Basically, a 1 inch filter is usually too restrictive in those levels. So you need a more powerful motor to be able to put up with the static pressure from that, or you can get a filter that is thicker. The thicker the filter, the easier that the air can flow through it due to the amount of surface area that filter provides. The thicker, the more surface area. So the more surface area we have, the more efficient the filter is as far as pressure differential. So we don't want too high of a pressure differential from the intake from each other side of the filter. So yeah, it could damage the filter if you put too high of a Merv rating on a filter that's not properly set up. So we can do that for you, or your HVAC contractor should be able to tell you what you need in order to put whatever type of filter that you're looking to put on there. or we can also select a filter for you that based on your criteria that you want to meet. I hope that answers the question. If not, let us know. So moving on to needlepoint ionization, like I said before, high voltage electrodes create reactive ions that react with airborne contaminants, including viruses. The design of the systems can be modified to create mixtures of reactive oxygen species and ozone, radicals, superoxide ions as well. The pros are they're very effective at removing smoke from air. They travel throughout the entire room, purge all of the air particulates. It bonds smaller particulate to larger particulate or makes larger particulate. We just don't want small particulate because it can damage our lungs. So we want to make pretty much all the dust, if you want to call it dust or just particulate in the air, we want to bind them together to make it bigger for them to settle onto the ground so gravity can do its work. And also needlepoint ionization, with it bonding these particulates together, can make your filter perform a lot better as well. The cons to this are some of these systems emit ozone, some at high levels. Manufacturers usually will give you the test data on how much ozone they make. Now you want to make sure that the ozone levels never exceed, I think the average down there right there is 0.070 to 0.10 parts per million for 8 hours of exposure. So just check with your, like, again, you have to trust your mechanical contractor, but definitely ask those questions. Say, does this produce ozone by how much levels as well? I think everybody knows about ultraviolet light, UV light. It's used quite often. It's very marketable for residential. The ones we see in residential space are not nearly as potent as the ones we see in the commercial space, but they do work on sanitizing filters. They work on sanitizing coils because they're exposed long enough. But basically, it uses UV light to sanitize anything it's exposed to. The problem is with proper exposure times, because we have, say, a 5-ton air handler can produce somewhere between 1,800 to 2,000 CFM. Those air molecules and viruses are passing by too fast for the UV light to really damage them. They need to be exposed to them for a certain amount of time, and it's longer than what you would see in an air system. So the pros are that it can destroy bacteria, fungus, molds, and some gases, and it does not reduce any airflow. So that's the pros. The cons would be the ultraviolet light has no effect on particulate. So again, we're talking about, we want to bind those particulates together so it's easier for the filter and we get it out of the air. It also needs direct close contact with the proper exposure times. One thing to look out for on UV lights, if you have any UV lights installed in your equipment and you are maintaining them, you want to make sure those lights are off before you open the equipment, because it's very damaging to your eyes and your skin. So you want to make sure those are off before you ever open a piece of equipment that has a UV light installed. Moving on to the RGF Guardian Remy Halo. This is a product that we sell. It's a combination of products that they've developed over the years between UV light and ionization, and it's pretty much a culmination of all of those. But they just released a study. They actually had the SARS-CoV-2 virus in their hands in a laboratory, did a third-party test, and it does kill 99.9% of SARS-CoV-2 in the air within an hour. So that's great news. We have this installed throughout all our branches in Florida, and we really rely on it to keep our office space clear. Here's a little video that kind of goes over the explanation of the product.
The high occupancy of commercial buildings makes them one of the most polluted indoor air environments. The Guardian Air Remy Halo by RGF can reduce these contaminants at the source. Installing easily into any forced air system, the Remy Halo is designed to recreate the natural way the environment removes impurities in outside air. It does this by sending out ionized hydroperoxides into the space where you work and breathe. attacking microbes like bacteria, viruses, and mold spores, destroying impurities like VOCs, chemicals, and odors in every cubic foot of air in the building at the same time. The REMI Halo even improves your existing filtration by causing the allergens to stick together, increasing filtration rates and energy efficiency without sacrificing airflow. Medical facilities using the Guardian Air have shown a decrease in MRSA cases, and long-term care facilities have saved tens of thousands of dollars by eliminating chemical odor cover-ups and increasing worker productivity. Public schools have shown a documented 15% decrease in absentee rates. The Guardian Air REMI Halo is the only product laboratory tested and proven to reduce the germs in a sneeze by 98% before they travel 3 feet. To find out more, visit rgfairpurification.com or talk to your local air conditioning and heating contractor to start breathing cleaner, fresher indoor air.
So yeah, that was a very great product. So if you have any questions about any of the products that we've talked about, just please give us a call or give your HVAC contractor a call, and I'm sure they can answer those for you or get you the right system for your application. So cleaning your ducts, a little play on words there. The EPA has reported that duct cleaning has not been proven to produce cleaner air, and they have consistently stood behind this report, which applies to all duct systems. In my opinion, it stands to reason that cleaning a metal duct or metal line ducts would be effective, and I've seen it be effective. There are many before and after pictures that represent what duct cleaning can do for metal ducts. The issue remains that duct cleaning can often dislodge matter into the airstream, as well as damage fiberglass ductwork and flex ductwork, which is usually seen in most of your office spaces. So use caution if you're going to clean some ductwork. Maybe better just to replace the ductwork depending on what the issue is. If you have an issue with ductwork, please let us know. We can give you the best option. We have done a lot of mold remediation and ductwork cleaning in Chase banks around Florida. So we have a lot of experience with it. So if you have any questions about it, let us know. And then preventative maintenance. The benefits of maintenance: saves money over the lifetime of the equipment, improves indoor air quality because we're changing those filters, cleaning those drain lines, keeps the equipment running efficiently. Properly maintained equipment are proven to use 15 to 20% less energy. Poorly maintained systems can increase energy usage up to 60%. Will extend the life of your equipment, reduce service calls, and reduce the risk of water damage, which is some of the worst damage that can be done by an AC system is water damage. Who should perform this maintenance? The maintenance should be always performed by qualified personnel on a routine basis. Technicians who are familiar with the property and equipment spend less time troubleshooting and diagnosing problems. So we usually, anytime we're doing maintenance, we have a particular technician that's registered for that property, so that way he knows the property, he knows the units, so that way it's the most efficient. If you do not have a maintenance contractor, at least have pre-qualified vendors.
I think next slide. All right, Paul?
Yep.
Okay.
Kevin, we had a couple questions in the Q&A.
Okay, awesome. Paul, if you could shed light on your opinion if the UV light could kill the COVID virus.
So yes, it can. UV light will eventually kill anything, pretty much. It's just the fact. So this is the thing with an air system, like we saw in the sneeze video, that will travel all the way back to the air handler. How many times will it infect somebody before it gets back to the air handler? And will that SARS-CoV-2 virus stay long enough exposed to that UV light to kill it? Now, it's all about exposure time. It's like, sitting in the sun and getting a suntan. It's about the amount of time you spend exposed to that UV light that can either cause damage or, not cause damage to the virus.
Awesome.
I hope that
One more question, which I think you're going to address at the end, but what is the ballpark for the REMI Halo? It's a multi-part question. Also, what's the useful life of them? And what's the impact on electricity rates? How many kilowatt hours do you see them using?
So the specifications on that, I do not exactly have. So, but I haven't seen any large, they're 24 volts piece of equipment. So it's not a lot of electricity being used. I can get you those exact details later. Now the ballpark for the systems, they can range from 1,000 to 1,500 depending on you know, what type of one you want. They come in two different types, LED and non-LED. They also, if depending on the size of your unit, we may utilize an array of them. So if you have a larger unit, usually the rule of thumb is 1 REMI halo per 5 tons. So if you have a 20-ton system, we'll do an array of 4 units. So just multiply that. If you're doing more than one, we usually can work on a better price for you. So just kind of get with me, or get, you know, we can get you up a price, and I'll also get those details on consumption. But I haven't seen anybody, we definitely haven't seen, we track our energy consumption. We haven't seen a large spike, and we have them all throughout the building. So I don't assume that's a large amount of electricity consumed.
Awesome. Paul, and then if someone does invest in them, how long do you think they would last?
So the lifespan on the cell of the LED unit is 4 years. It comes with a 5-year guarantee. You want to check those once a year, so your maintenance contractor or us can check them once a year. To replace the core is about $650. So every 4 years you have to replace the core. It's definitely, if you look at the cost of MERV 11 to MERV 13 filters, it definitely outweighs the cost in almost, I think, 2 visits of MERV 11 or MERV 13 filters. And it's going to make your filter perform, you know, your MERV 8 filter or less perform about the same as a MERV 11 and MERV 13.
Awesome. Appreciate that, Paul.
Yep.
All right, up now we got a Riverside Hotel project. This is a pretty neat project, in my opinion. It shows how when we do a re-roofing project and an HVAC project at time, you can make some pretty magnificent things happen. We'll go into a video in here in a second, but this project had wall mount old school HVAC units in all the hotel rooms. If you guys know the Riverside Hotel, I believe it was built in the 1940s. So, and been added on throughout over the years. So we had to retrofit this building with new mini split units up on the roof on stands, and then design custom architectural metal to get the refrigerant pipe down into the buildings. And it just shows how when you hire somebody to do a roofing project and HVAC project at one time, it makes a very successful project on bringing this building up to 2020, you know, code and standards as far as HVAC goes, and efficiency at the same time. They went from a black roof to a white roof. They went from wall mount units to split, very efficient units. Go ahead, Jeff.
My name is Jens Heredia. I'm construction manager for Advanced Air Systems. It's a huge upgrade we have done throughout the classic side of the hotel in conjunction with the roofing scoop. The classic side of the hotel, it did have a type of window shaker units, you know, typical small hotel. We had done here 149 units of split system throughout each room for the classic part. And also we had done a couple outsider units. One is a 25-ton, the other one is a 20-ton that fit all the hallways area. The electrical side of it was part of the project as well, all self-performing and designed by Advanced Air Systems with our electrical department. At the end, any owner out there will go with, you know, Advanced, okay, the big picture, because of all the capability we have in-house. You know, having electrical, having HVAC, and having roofing, you know, which represent the whole company.
So at the end of the day, it just shows that there was no finger pointing on a project. We were able to go out there and do a whole turnkey project above the roof with whether it's split units, chiller units, big outside air package units. And there's no GCs involved. There's no he said, she said, and it was a very successful project. We do these day in and day out for actually a lot for Broward schools, Palm Beach County schools, and a lot of high-rise condos throughout the beach when they're going to do their chillers and roofing. It always seems to happen at the same time. So we go out there and do a turnkey solution across the board. So there's 5 years down the road and there's a leak, there's one person to call to come out and diagnose what's going on and resolve the issues. Because in this day and age, there's nothing's ever going to be perfect. You're always going to have something you're going to need to work through as a group, and we'll be there for that.
Awesome. Appreciate Mike walking us through that. So appreciate everyone's time today. If there's any questions, put them in the chat board or the Q&A section. Also, remember, if you want the CAM credit, put your email in there so we get you the certificate. I did want to highlight again, just our next upcoming webinar, March 9th, solar energy. Clint, I don't know if you could just touch a little bit, a highlight preview of what everyone could expect there.
Yeah, absolutely. Happy to. We have a great lineup. We're bringing in some manufacturing partners to talk about structural racking systems and attachment into buildings, which is always a big concern for our owners and property managers and the folks that have to maintain buildings. So Iron Ridge, one of the world's leading manufacturers of solar rackings, coming in to talk about their products and how they design to minimize attachments into buildings. And when we do have to attach, how we address that. We're also going to talk about paybacks in regards to federal tax credits and depreciation. So really kind of giving a high level overview of how we integrate into buildings and everything that's going on in regards to the financial returns and the investment profiles of these renewable assets. So that's a great thing. Also did some real quick math for Paul, but that Remy Halo is very efficient. So 24 volts at less than 1 amp. It's drawing about 17 watts. And over the course of a year, it's under 200 kilowatt hours, which we in Florida pay on average about 10 cents a kilowatt hour. So it's less than $20 a year to run one of those units. So very fuel efficient. And, like Paul said, they need to be sized for however many units you have, but that's kind of a per unit figure. So really amazing technology to look at.
Thank you, Clint.
Awesome. Go ahead, Paul.
Yeah, no, there's all my contact info. If you have any questions, feel free to reach out to me. I'm available by phone, email, whatever you need. Just reach out. I can help you out with whatever questions you have, whether they're IAQ related or just HVAC related in general.